Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the moon hopping series that I'm doing, where I'm starting off on Jupiter's moon, Callisto, and then we're going to hop down to Ganymede, land, and then from there hop up and go over to Europa, land, and then go from Europa to Io and land. Now, the reason I want to do this video is because I've learned a lot about using IMFD thanks to the training videos that I did with Dimitri, plus all the time that he spent with me off camera and through emails. And I feel like I can create a series of videos that will have a lot of explanation, a lot of meticulous explanation of how to do this kind of flight. And I think if you watch it, the whole series, especially, then by the time you get to the end of it, especially if you've practiced what we're doing here, then you too will have a great understanding of IMFD, at least the basics. There's always going to be more to it than what we can cover in one series, but by the time you do all this, you should have a pretty good intuition and a good insight in how to use this IMFD. If you're coming to IMFD like I would have been just a few months ago, where it's just a total mystery to me, then I think this series will really help you accomplish a lot of things. So let's go ahead and switch camera views here. And in the last video, I believe we were at Callisto. We warped time forward, did a little bit in the way of mid-course corrections, and now we're only 60,000 seconds away from getting over to Ganymede. And one thing I forgot to take into account was getting lined up with the base, but we aren't that far off from the our orbital plane around Ganymede's not going to be that far off from Ganymede base. So we could just go ahead and go all the way to Ganymede and not worry about it. But I think it would be better to go ahead and plan on arriving at Ganymede, which is over here, when we already have some kind of plane alignment with the base. Ganymede, again, I believe, let me check its orbit real quick. Let's reference Ganymede. I don't believe it orbits very fast. I can't tell from this what I'm looking for. What I want to know is what its orbital velocity is, and that's not telling me. That's just telling me what my velocity is relative to Ganymede right now. But I don't believe it orbits. I don't believe it rotates very fast. In fact, I know it doesn't. It's tidally locked with Jupiter. So the point is that we can align our base now, and we don't really have to worry about it being really far off by the time we get over there. Whereas with Earth, if you do your base alignment too soon, then by the time you get to where you're going, the Earth rotates so fast that you'll be completely out of alignment. Okay, so let's bring back up Map MFD. Now, we could do this a couple of ways, I suppose. The generic way to line up a base is to bring up, Map MFD, and then go, normal plus, normal minus, and watch your orbital plane. I don't think we can actually do that until we are within the strong SOI of Ganymede. And the problem there is that by the time we get within the strong SOI of Ganymede, it'll probably cost us a lot more. So what I want to know is if I can figure out how to do that before we get to the strong SOI of Ganymede. And I don't know necessarily, I'm not quite familiar enough with IMFD yet to know how to do that. I believe we want to go to the menu, then course, and we want to bring up probably the planet approach, or would it be orbit insert? Probably planet approach. Now we need to reference the body that we're going to, which in this case is Ganymede. And it's not planet approach. Must be base approach from here. Now we want to reference Ganymede and target where we're going, which is Ganymede base. And we want a approach for probably orbit insert. Now, The thing I'm not sure about, though, is... Okay, this is the latitude and longitude, and it's correct, because you can see the Ganymede base, but... I believe this will have an EQI that's almost 180 degrees opposite of what we're on right now, because remember, we are on a retrograde path toward Ganymede. We're going to arrive at 165, and we don't necessarily want to change all the way to the other side because Ganymede doesn't have an atmosphere to worry about. So let's see if we can change that. But how do we do that? Because you can't select it as an option. So, and that's obviously an expensive correction. I don't think it would cost nearly that much. We may not actually align our base. It would be better if we could, and I should have thought about it sooner. But we may just go ahead and get into orbit around Ganymede and then go from there. Or at least get down to where Ganymede's a strong SOI and then do the base alignment, which is also expensive. It would be ideal to do it out here, but I'm not sure. Wait a minute, here we go, prograde, retrograde. That's probably what we needed to change, because you can see that immediately cut the delta V in half. I think that's what I was looking for. And then also the altitude, when we get there, we don't need that to be any more than like 30. I don't know if that'll help our DV or not. It doesn't. Okay, I think that's what we have to do. So bring up base approach, reference the body, which in this case is going to be Ganymede, reference the target body, then target the base you're going to, which is Ganymede base in this case. Then for the altitude, actually, we have to set 30K, because that's 30 meters. I often forget to do that. Then we want, for approach 4, we want approach for orbit insert. Or maybe even, yeah. I don't think we want re-entry. Yeah, no, we don't want any of those for sure. So approach for orbit insert, and then we want to make sure that what we're doing is in alignment with how we're going to arrive at the target. And in this case, we're arriving retrograde, and we don't want to change that, because if we set it to plus, then it's going to move our trajectory all the way to the other side of Ganymede, and that's an expensive amount of delta V. But I'm still a little concerned that we're spending a lot more than we have to using this program. My gut tells me that if we get closer, it's going to actually go down in cost, even though the TEJ says otherwise, because if we add in time, you can see the TEJ says it's going to cost us more, but due to the inaccuracy of this program, I'm just not sure. Let's trust it. So we'll set the TEJ to 0, so we'll do the burn right now. And I'm not going to add this part to my notes because I'm not real sure. So when we do the next hop, then I'll add this part. I'll add the base alignment planning to the notes, but for this part, we're not going to. All right, let's bring up the Interplanetary's map program on this side. And we've lost our reference, so let's reference Ganymede. And it's already set to PE. So let's mod over to here. It looks like we've also lost our configuration, so let's go to configuration, landing target, set to Ganymede base, or maybe I just didn't do it before and I thought I did. Now let's go look at the map program and mod. And I believe this is the default page, and we want to go mod until we can see here Ganymede base. This shows us our angle. I wonder if we can do this. Menu, share, with the side 0. Make sure I'm not sharing over here. Okay. And now bring up map. And I wonder if we can look at this on here. Plan. Yeah, let's do it that way, because this is just obviously not right. According to map IMFD, if we do that, we're going to have our PEA at 8,000 kilometers, and our angle is going to be way off. So, but we also don't have like delta velocity type of options here. So let's do this. Page, burn vector, and let's set this up as a delta velocity maneuver. So we'll unshare this side, go to course, go to the delta velocity program set, and we'll give ourselves 4 minutes, so 240 on the time. And now we'll start by putting this in, and then we'll make adjustments as needed. So select, set, negative 50, let's call it negative 60 because it's right there. Set negative 51. Now set 260, 270. All right, now we've got that. You know what, though I forgot to target. Let me think about this for a second. I guess that doesn't matter. Let's bring up map IMFD now on this side, or map the map program, but first we have to share. And I'm not sure if I'm doing this right, so again, that's why I'm not making notes on this part. So now we have the map program over here, page over, plan, and SOI, display, auto zoom off. Now, this is basically what base approach was telling us to do, but let's see what happens if we tinker with these variables a little bit. Ganymede base, we want the angle to be 0, and we want the PEA to be 5, 10, something like that. So first of all, let's see if we can take away some of the velocity. And let's go ahead and set this back to 240. Actually, let's go 300. Just to give ourselves time to set this up, since we're sort of learning what we're doing here as we're going. Let's start with DVI because it's the biggest number. Let's go to an adjustment of 10. And I'm taking away what it tells me to do, because that would bring down the total delta V. And that's getting me closer, which is what I want, but it's raising the angle. So let's kind of let's just arbitrarily bring the DVI down to that point, which cut our total delta V way down. And let's now see what plane change is needed to bring down the angle. And you can see that's bringing down the PEA and the angle. Okay, now let's go back to DVI, take out some more, because that was bringing down the PEA, but you can see we've overshot. We have to add in some more plane change. But I think this is probably the better solution than just using base approach. Okay, we're pretty close on the PEA. Now let's go back to plane change, because now our distance off base, that's going the wrong way though. Okay, now watch the PEA, it's below the surface. Let's go back to, let's see if we can do some with prograde, maybe take out some prograde. That's helping. DVI, not helping the angle, so let's help the angle. Get it closer to 0. Let's go about there now, because we still need to make adjustments to the PEA, and that's going to have some impact on the angle. It looked like DVI was helping the most in this regard. So that's bringing the PEA down, but it's raising the angle. That's bringing down that's okay. Bring down the PEA, but raise the angle. Then go back to plane change and bring down the PEA and the angle at the same time. Now we've got 0 and we've got 278 there, so we're getting really close. But we need a little bit more, so a little bit lower on the PEA. Now take out a little bit more plane change. And that's a good solution there, I would say. If we do an adjustment of, bring the adjustment down to 1, we can probably get the angle to 0. Certainly good enough, I suppose. If we really want to be picky, could do an adjustment here as well. There we go. Now we've got it at exactly 0. Okay, I think that's what we want to do, and we've only now got a burn of 67 meters per second, so it's a heck of a lot cheaper than what that other program was showing us. So let's commit to this burn, see what happens. So page over. Just let me think for a moment. Let me also target the equator. Make sure everything still agrees. It does. Let's burn. So auto burn. And again, I'm not going to put this step in the notes because I'm kind of fudging my way through it here. And when I do the hop from Ganymede to Europa, we'll kind of refine this part of the notes. All right, 76 seconds to burn, until the burn. Burning. And burn's complete. It's almost complete. Turn off the plan. And when the plan is off, we can see that the real-time update says 33 kilometers and the angle is 0. So we should now have a orbit that will take us over top of Ganymede base. We don't have the orbital plane showing quite yet because we're still far enough away from Ganymede that we only have a 0.01 gravitational influence, and that's because Jupiter is such a pig that it's dominating our gravitational field wherever Jupiter's at. As large as it is, you'd think it'd be super easy to find. Anyway, oh, there it is. So there's Jupiter, and there's Ganymede. Okay, now let's fast forward time. Let's get closer to Ganymede, and hopefully we'll get close enough that we'll be able to see our gravitational influence increase. Notice the PEA according to Orbit MFD is coming way down. PEA according to Interplanetary's map program is it's bouncing around a little bit, but it's holding pretty steady. So I think if we had done what we just did a little bit sooner, we could have saved a little bit of delta V. But 70, I think it was about 70 meters per second, is not too horrible. Let's see, what is our PET? We're down to 44,000, so about a half day out. PEA, according to this, MFD is coming way down. This one's holding steady, pretty steady. Let's see if we're probably not close enough yet to get information from map MFD, but let's see. When you get close enough, this orbit line will actually change, and you can actually see what your real orbital plane will be when you get there. But right now, we still don't have enough gravitational influence for that to show up. So let's just continue warping time forward. PET's down to 30,000. Angle is okay. It's there. Watching the PEA. Maybe if I zoom out a bit, I can see where I'm at. Oh, there I am. Okay. That white dot, which is now visible in this zoomed in level. Let's go ahead and warp time forward. Keep going forward. I guess we're not going to get into the strong SOI till we cross that. So now we have that information. 10,000 seconds out. And if we did this right, then there we go. And apparently we did it right, because you can see that our orbital plane has us passing over top of the base. So clap for us, little pat on the back for figuring something out. Okay, so we're only 4,000 seconds away from lowest point. All right, so now it basically, there really isn't a lot of new information here. I would say that all of our IMFD planning and thinking is over with. All your normal orbital physics apply at this point. In fact, we can just do everything else now without even using MapMFD, or rather without even using IMFD, but I think we can still get a little bit of benefit out of it. One thing we can certainly do with it is use it to circularize our orbit. We're not going to try to do something fancy here where we're going to arrive 500 kilometers ahead of Ganymede base and then just do a braking burn and land right away. We're going to get into orbit first. It does save a little bit of fuel in some cases to go straight into the base, but in most cases it's not. I don't think it's a big deal. I know Dimitri told me when you do that at the moon, you can in some cases save some fuel doing that, but I don't recall it being a big number. Okay. And I apologize for popping my tongue like that. I'll try not to do that. It's got to be irritating in the video playback. So let's leave map and Interplanetary's map on that side. Let's bring up Interplanetary on this side. Are we sharing? Yeah, let's unshare. We don't need to share anymore. Of course, I believe that's going to reset it, and it does. That's okay. Projection to self. And if we press target L, that targets the equator, which gives us the information that we need for our EQI. Over here, we're going to bring up, I think the correct program now is, we want orbit insert, I believe. There's a couple of ways you can do this. You can just use orbit, Interplanetary's orbit circularization program. But I think orbit insert is a little bit easier. So we bring up orbit insert, and the time to do the insert is the TEJ. Of course, you can't change it anyway. The only thing you can change is either orbit insert, which actually I guess you can't even change that. So either eccentricity, so apoapsis, major axis, and we're going to go, I guess, for eccentricity. I guess these are just different ways to define how you want your orbit to be circularized. Again, I'm going to change the projection to self. I just like the way it looks better. And according to this, we need a circularization burn of about 1,113. That pretty well agrees with what we saw when we originally set this up while we were sitting on Callisto. I didn't write down exactly what that number was, but I know it's close to that. And again, that's because Ganymede has no atmosphere, so we can't just simply do an atmospheric braking maneuver. So if we do this at that time, then MapMFD says this. So says it's going to put us a little bit off angle with Ganymede base. So what if we do base approach instead? Maybe that's what we need. Approach for orbit insert. Actually, I think this is the one we just did, right? Yeah, this is the one we just did. So that's not what we want. All right, forget that. Let's do course orbit insert. You know what? I'm just going to do this the way Dimitri showed me, because if I use the orbit insert program, I might get it wrong. So let's just go to orbital circularize. And what we're going to do, this is the same thing that I did when we went to the moon. As we get closer to periapsis, and I guess here now we can shut off the plan, we will begin the braking burn when we have the burn time total that we need is 126 seconds. So we're going to start the burn when we're half that number, but right now this number is not correct. So we want to get closer to the burn time. Remember, you always want to start your burn half of whatever the burn time is. So this would be 60 seconds in this example, or about 63 seconds. So we want to go forward until we are at least 63 seconds from periapsis. But at that point, we may find that our burn time is no longer, that much. It may be much lower. So let's just go forward first of all so we can see what we're talking about. PET is 3,000. Let's go way down. See what I'm talking about? As we get closer to periapsis, this information's updating. So now instead of 60 seconds, it would be like 51, but we still have a ways to go. Okay, now what we'll do, we're only 200 seconds out, and it says the burn time total is going to be 82 seconds. So we're going to go to 41 seconds, and we're going to get this set up. But what we can do here also, since we're getting close, we can press AB to let the vessel orient itself, or we can just do it manually. But be careful if you press AB to let IMFD orient, because if you just press AB and let go, it's going to burn right now, and we don't want to burn right now. We want to burn 100 seconds from now, 140 seconds from now. But if we press AB, let it orient, and then right when it gets to the middle, I see I missed it by a second. You want to press AB again. So it's probably better, you're probably better off just orienting manually like that. Now we're in position. Now we want to go forward until the PET here is half of that number, which is, again, it's going to be about 40 seconds. And you can see as we go forward, it changes. But when we're at about 40 seconds, it'll be right. But we can check in again at like 60 seconds. Okay, there's 60 seconds. So let's see, now it says 79. So yeah, again, 40 seconds is going to be about the right time to engage. So get ready to engage when PET is 40. Warp time 4, there we go. 3, 2, 1, and circularizing. And I guess I should have done that a second sooner because we needed to align a little bit, but now we're getting our orbit circularized, and we can warp time forward because that's 1,000 meters per second that we have to burn through. Coming up onto the end of the burn, and burn complete. Well, almost. Okay, now the burn's complete. Now let's check orbit MFD for information. You can see the burn, the orbit circularization did a great job of getting us into a circular orbit around Ganymede. Now let's check map MFD, and we are approaching Ganymede base. If we want, we could pretty much brake on this initial pass and land. If we want to be a little bit more efficient, we can go all the way around to the other side, bring down our PEA, but most likely I think it's going to be best just to go ahead and try to brake and land right away. Close to 30 minutes on this part of the video, so let's go ahead and wrap it up here. If you like this video, hit the like button. If you didn't like it, hit the don't like button. Thumbs down. You suck. That's what it says. No, actually, I don't really care about thumbs up and thumbs down, but I do care about comments. I like when you leave comments on the videos because it lets me know that you're participating. It lets me know that you are informed, that you care. If you don't leave a comment, I don't think you care. And plus, when you leave comments, other people that watch the video see your comments, and they might have something to say that they wouldn't otherwise have said because you didn't comment. Check for links in the description down below. Whereas with Earth, if you do your base alignment too soon, then by the time you get to where you're going, the Earth rotates so fast that you'll be completely out of alignment. Okay, so let's bring back up map MFD. Now we could do this a couple of ways, I suppose. The generic way to line up a base is to bring up, map MFD, and then go, normal plus, normal minus, and watch your orbital plane. I don't think we can actually do that until we are within the strong SOI of Ganymede. And the problem there is that by the time we get within the strong SOI of Ganymede, it'll probably cost us a lot more. So what I want to know is if I can figure out how to do that before we get to the strong SOI of Ganymede. Okay, welcome to another Orbiter 2010 video, and this video is going to be a continuation in the moon hopping series that I'm doing, where I'm starting off on Jupiter's moon Callisto, and then we're going to hop down to Ganymede, land, and then from there hop up and go over to Europa, land, and then go from Europa to Io and land. Now, the reason I want to do this video is because it's I've learned a lot about using IMFD thanks to the training videos that I did with Dimitri, plus all the time that he spent with me off camera and through emails. And I feel like I can create a series of videos that will have a lot of explanation, a lot of meticulous explanation of how to do this kind of flight. And I think if you watch it, the whole series, especially, then you'll, by the time you get to the end of it, if you, especially if you've practiced what we're doing here, then you too will have a great understanding of IMFD, at least the basics. There's always going to be more to it than what we can cover in one series, but by the time you do all this, you should have a pretty good intuition and a good insight in how to use this IMFD. If you're coming to IMFD like I would have been just a few months ago, where it's just a total mystery to me, then I think this series will really help you accomplish a lot of things. So let's go ahead and switch camera views here. And in the last video, I believe we were at, at Callisto. We warped time forward, did a little bit in the way of mid-course corrections, and now we're only 60,000 seconds away from getting over to Ganymede. And one thing I forgot to take into account was getting lined up with the base, but we aren't that far off from the orbital. And I don't know necessarily, I'm not quite familiar enough with IMFD yet to know how to do that. I believe we want to go to the menu, then course, and we want to bring up probably the planet approach, or would it be orbit insert? Probably planet approach. Now we need to reference the body that we're going to, which in this case is Ganymede. And it's not planet approach. Must be base approach from here. Now we want to reference Ganymede and target where we're going, which is Ganymede base. Our orbital plane around Ganymede is not going to be that far off from Ganymede base. So we could just go ahead and go all the way to Ganymede and not worry about it. But I think it would be better to go ahead and plan on arriving at Ganymede, which is over here, when we already have some kind of plane alignment with the base. Ganymede, again, I believe, let me check its orbit real quick. Let's reference Ganymede. I don't believe it orbits very fast. I can't tell from this what I'm looking for. What I want to know is what its orbital velocity is, and that's not telling me. That's just telling me what my velocity is relative to Ganymede right now. But I don't believe it orbits. I don't believe it rotates very fast. In fact, I know it doesn't. It's tidally locked with Jupiter. So the point is that we can align our base now, and we don't really have to worry about it being really far off by the time we get over there.